So now when we put the stuff in formula form with lots of letters for variables, things always look more complicated than they are. But using two symmetric points to find the vertex of a quadratic function. So if we think back to this prior example where we had a point at 2, 10, and 12, 10. Okay, so these points both were at the same height, symmetric about the axis of symmetry. And so the x-coordinates were at 2 and 12. And so to get that axis of symmetry, we average those two endpoints to get our x equal to 7. And then to get the output, we would have to put that then through the function. Okay? Well, when we write that in kind of generic terms with all the letters, so if we have P, the point PS, and the point QS. So we should notice again that these would both have the same height. Okay? And then we would take the average of P and Q. So we'd take P plus Q and divide by 2. Okay? Just like we did on the prior part, that would give us our midpoint. And so here's P, and here's Q, and here's the point P plus Q divided by 2. It would be midway between those 2 points. And then to figure out the height of that vertex, we would take that number and plug it through the function. Now, again, we don't know what this number is just yet, so this looks kind of ugly, because in here we're going to have P plus Q over 2. Okay, so it's like our prior one where we did 2 plus 12, which was 14, divided by 2, we got 7. This was a number, and this was f of that number, f of 7. So you shouldn't memorize this formula, but you should understand it by drawing a picture. This should make sense as we look at graphing the points. The line of symmetry is where you can fold the graph in half and get mirror images left to right. We can find that x value by computing the average x values of the two symmetric points. Then to get the vertex, you do need the corresponding y-coordinate that makes the equation true. If it's going to be a point on the graph, it has to make the equation true. So you evaluate the function at that x value you just found to see what that corresponding output value would be. So example 4 says, use the given function to answer the following. So the first thing that we should notice here is that we have a quadratic function. We have the necessary x squared term, and then we can have optional x terms and constant terms, which we do have here. So the first thing says to verify that these are points on the graph of f. Okay, well, if it's on the graph, then it must make the equation true. Okay. So again, this is our x and y. You can think about this as equals y. And so before we substitute for a variable, we are going to place parentheses around that variable. So we're going to get -1 squared minus 4 times -1 plus 7 equals y. Okay, so again, these parentheses are important. We need that whole quantity, -1, the whole quantity squared. Okay, so now -1 times -1 is a positive 1. -4 times -1, we get positive 4, 7. And if we add here, we do get 12. Okay. Oops. We know what y is. Let's plug that in there. Okay, so again, we replaced the x's with -1 and we substituted 12 for y. Okay, and so we plugged that in and we got a true statement. Okay, so we know that the point -1, 12 is on the graph of f, because by definition that's what our graph is. It's a way to picture all the ordered pairs that are solutions to this equation. All right, so now let's try the point 5, 12. So now we've got 5 squared minus 4 times 5 plus 7. I want to know if that equals 12. Well, 5 times 5 is 25, minus 20 plus 7. So 25 take away 20 is 5, plus 7 is 12. So we get this statement 12 equals 12, which is true. So this point 5, 12 makes the equation true, so it also must be on the graph of f. Well, these 2 points are symmetric. If we were to think about plotting those points, we would go -1, 12, and then we plot a point at 5, 12. Okay, so these 2 points would be at the exact same height. They're both up 12. Okay, so that vertex has to lie somewhere on this axis of symmetry that cuts down between these 2 points. So this was at -1, and this was at 5. Okay, so we need to find the point, the value of x that's midway between those. Okay, so we're going to take, so if we find the average x value, that would give us 5 plus a -1 divided by 2. And so this would give us 4 over 2, which is 2. Okay, so that should make some sense because this distance would be 3 and this distance would be 3. Okay, so that would be our midpoint. We have equidistant to each of those endpoints there. Okay, so that gives us the x-coordinate of the vertex. And so now to get the y-coordinate, we would need to see what the output for an input of 2 is. So f of 2, we would get 2 squared minus 4, and again parentheses around the variable before we substitute. And so f of 2, we would get 4, take away 8, plus 7 gives us 3. And so our vertex, the input would be 2, midway between -1 and 5, and then when we plug that in the function, it gave us a corresponding output of 3. So our vertex would be at the point 2, 3. All right, so now it says to find the y-intercept and use symmetry to get coordinates of yet another point. Okay, so again, by definition, our y-intercept is the y-coordinate when x is 0. So we want to know what the output is when the input is 0. So if we do f of 0, we're going to get quantity 0 squared minus 4 times 0 plus 7. So 0 squared is 0, 4 times 0 is 0. So here we're just going to get plus 7. Okay, so our y-intercept is at the point input was 0 and output was 7. So now let's take a look at the graph to get the other point. Okay, so on our graph here we have a point, our y-intercept is at the point 0, 7. We said our vertex was at the point 2, 3. Here's our vertex at the point 2, 3. So now that puts our axis of symmetry right here with the equation x equal to 2. Okay. So if from our axis of symmetry to here, this is a distance of 2. So directly across, again, another distance of 2, there must be a point here as well, and that point would be at 4, 7. Okay, so if we use that axis of symmetry to get another point, that other point was at 4, 7. So now we're asked to graph f of x equals x squared minus 4x plus 7. It says to label the vertex, which we did, the axis of symmetry, and any intercepts. Right, so we have our y-intercept, and here's our vertex. So our graph is going to come down through this point. The vertex is its turnaround point. And so this graph will not have any x-intercepts. Again, it doesn't get any lower than this value here at 3. And to have x-intercepts, we need the y-coordinates to be 0.